Welcome back to The Explainer. I am so thrilled to have you here today. If you've ever dealt with the absolute headache of connecting countless client apps to this ever-growing web of back-end services, well, you know how quickly things can spiral into total chaos. Today, we're talking about transforming that chaotic tangle into a streamlined, highly secure architecture using Azure API management. So, here's a question for you. How do you protect a public-facing API without actually exposing your backend? When I first came across this, it kind of sounded like a trick question, but it's really the most critical architectural hurdle modern developers face. Leaving raw backend services open to the internet is a massive vulnerability, and yet it happens literally all the time. Okay, let's dive into this. When you just publish an endpoint out there, say an unprotected Azure function, you're essentially operating in the Wild West. Exposing raw backend services doesn't just risk your security, it absolutely spikes your compute costs. I mean, imagine a botnet finding your unprotected endpoint. They can hammer it relentlessly, and suddenly, boom, you're footing the bill for thousands of bogus executions. No thanks. So here is our roadmap for today. We're going to cover the gateway concept, the anatomy of API management, securing the front door, smart caching for speed, and finally, keeping a watchful eye with observability. Let's get moving.
Section 1. The gateway to your data, moving from chaos to control.
And this brilliantly illustrates the core concept. Think of your API gateway as the ultimate bouncer and concierge, kind of rolled into one. On the left side here, direct backend access. That's like leaving the club doors wide open. It's incredibly high risk. I've actually heard nightmare stories of leaked API keys getting scraped from public code repos, costing companies tens of thousands of dollars overnight in compute charges, just because they were paying for every single piece of unthrottled traffic. But the managed facade on the right, it checks IDs, enforces rate limits, and completely abstracts the backend. The client has literally no idea if they're talking to a modern Azure function or some legacy database. Section 2. Anatomy of API management. The core components. Before we really get into the technical weeds, let's pin down the core concept here, a facade. In software architecture, a facade is a protective, intelligent layer that abstracts backend diversity and complexity from consumers. So when you use Azure API Management, or APEM, you're building a facade. Your consumers only ever talk to the facade. They never, ever talk to your backend directly. APM actually has a few distinct personalities serving different audiences. First up, the API gateway, or data plane. This is the runtime that actually routes the requests, verifies the tokens, and enforces quotas. Second is the management plane, or control plane. This is where your admins configure the settings and group APIs into products. Third is the developer portal. Think of this as the self-service VIP lounge where external or internal devs can read your documentation, test out the APIs, and grab subscription keys. And finally, workspaces. This is great because it empowers decentralized teams to manage their own APIs while still giving the central IT team that ultimate oversight. Section 3. Securing the front door. Locking down access. All right, let's walk through how this OAuth 2.0 authorization workflow actually plays out step by step using Microsoft Entra ID. Step 1, the client application authenticates with Entra ID and gets a JSON Web Token, or JWT. Step 2, the client attaches that token to its request and hits the APM gateway. Step 3, and this is where APM really shines, it intercepts the request and uses a validation policy to verify the JWT. It checks the signature and the claims. Step 4, only if that token is absolutely valid does APM forward the request to your backend. So the backend never has to worry about authentication. APM just handles the whole shebang. So the crucial point is this. The real game changer here is absolutely system-assigned managed identities. How does APM securely talk to your Azure functions behind the scenes? Well, in the old days, you'd copy and paste a function key. But as we just discussed, those can be leaked. With managed identities, Azure essentially gives your APM instance its own unfakeable identity. You just tell your Azure function, hey, only accept traffic from this specific APM identity. No shared secrets, no hard-coded keys. It is brilliant. Beyond identity, we need to put a few extra locks on the door, right? Always disable deprecated direct management APIs to shrink your attack surface. Never store secrets directly in APM. Keep them tucked away securely in Azure Key Vault and just reference them. Definitely apply rate limits. If a bad actor tries to hit your API 1,000 times a second, APM blocks them before that traffic ever reaches your expensive compute resources. And finally, use virtual networks to ensure your backend only ever accepts traffic originating from the APM subnet.
Section 4. Built for blazing speed. Smart caching strategies.
The absolute best way to reduce backend load is to stop asking the backend the exact same questions over and over again. APMs kind of remembers repeat guests, you know? For reference data, like a list of countries, cache it for hours or even days. It doesn't change. For search APIs, cache it for 30 to 60 seconds. A slight staleness is totally fine, and it completely absorbs massive traffic spikes. For a single resource, like a specific order ID, 5 to 15 minutes is usually pretty safe. But for real-time data, like stock prices, do not cache it at all, unless you want to bankrupt your users with stale data. Always match the time to live, or TTL, to your actual freshness requirement. Implementing this is actually incredibly simple using XML policies. An inbound cache lookup policy intercepts the request. If APM already has the data, it short-circuits the entire process and instantly returns the response. If it doesn't have it, it forwards the request, gets the data, and then an outbound cache store policy saves it in the vault for the very next user.
But hold on, here is a massive warning you absolutely must pay attention to. If your API returns personalized data, like a user profile, you cannot share that cache globally. You absolutely must set vary by developer to true. This forces APIM to create a separate cache entry for every single authenticated user. If you forget this, user A might accidentally see user B's private bank details just because they hit the API a millisecond later. No way do you want that.
Section 5. Keeping a watchful eye, observability, and monitoring. To install our virtual security cameras, you've got an incredible suite of native observability tools right at the gateway. You have Azure Monitor for high-level metrics like CPU usage and baseline error rates. You've got Application Insights, which is just incredible for end-to-end distributed tracing. You can see exactly how long a request spent at the gateway versus the backend. You can use Event Hubs to stream logs in near real time. And for the devs out there, the API Inspector lets you trace individual requests step by step for instant debugging. Now, what's really interesting about this slide is the core philosophy behind it. Observability prevents minor faults from becoming system-wide outages. Monitoring isn't just about logs, it's about guaranteeing reliability. If you see your cache hit rate plummeting in Azure Monitor or your rate limit violations spiking, you can jump in and intervene way before your backend Azure functions are completely overwhelmed and taken offline.
Summary. A unified ecosystem. Bringing it all together. By dropping Azure API management in front of your raw backend, you offload all the heavy lifting. The gateway handles the OAuth 2.0 validation. It throttles the bad actors, it caches responses to save you money on compute, and it logs every single interaction so you never have to fly blind. It dynamically scales and completely protects your architecture.
Which leaves us with one final thought to ponder. Look at your own digital infrastructure right now. Ask yourself, is your backend an open target just waiting to be exploited or overwhelmed? Or is it a fortress neatly tucked away behind an intelligent, scalable facade? The choice is yours. Thank you so much for joining me on this explainer. Keep learning, and I'll catch you in the next one.